We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.
There she is, NASA's Voyager 1, launched in 1977.
But that's just very small potatoes compared to what the Earth is involved with and knows about.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
Hello, greetings, and good day, and welcome to episode 15 of Space, the Final Frontier. This is your Kaspacer and Space Commander, Professor June Cahigal. Now, Space, the Final Frontier is a series of online lectures that is intended to help and inspire our students out there to love the sciences, especially astronomy. So for this episode 15, we will be having again a special guest. And this is fitting because we will conclude global Global Astronomy Month 2021. Our guest speaker for tonight is one of the co-founders of the Manila Street Astronomers. A good friend of mine, so he is no other than Mr. Christopher Lu from the Manila Street Astronomers, who will give us a lecture about exoplanets. So, if we have any questions or comments or reactions later about his talk on exoplanets, please feel free to type in your questions, your comments, or your reactions in our comment section below. Wag po kayong mahiya, and we would be very happy to answer all your questions and queries. So this talk is special because we will conclude Global Astronomy Month 2021, and what fitting to conclude GAM 2021 by having this talk of Christopher Lu from the Manila Street Astronomers. So come join us as we travel where no man has gone before.
Good evening once again, BSYA, and to all astronomers that are going to be watching our webinar, and welcome to our last Global Astronomy Month webinar. Global Astronomy Month is an international celebration of space, flight, and all things that is related to astronomy. It was initiated by the Astronomers Without Borders, and this year will be the first year for the BSYA to celebrate it. This is a month-long celebration with all the organizations all around the world who live astronomy as much as we do.
With Shiva. Hi Shiva,
Yay!
so kamusta naman?
Okay rin naman. Too bad nagkaroon ng technical difficulties sa side ni na Sir Lu, di ba?
Oo nga eh.
Hello?
So, okay naman ako. Kumusta ka rin?
Okay, so ako ay stressed. Actually, ang dami yung performance work ngayon. But yeah, I'm still catching up.
Tinatamad ka bang gumawa ng mga performance?
Ay, hindi naman. Light lang. Pero yeah, I'm still working naman. Gumagawa pa din naman ako.
Light lang. Ano yun?
Yes. It means. Charot. Oh my God. Shiva, you're grade 11, right?
Yep.
So far, kamusta naman ang BSYA sa'yo?
It's exciting naman since we get to be talking about, astronomy. Like, every webinar we talk about astronomy and it amazes me. Like, astronomy is pretty amazing if you look at it at a different perspective. It's like a sign of how far we have gone as humans. So, ate, what do you think, kumusta na rin naman po yung experience niyo po sa BSYA? May I ask you about that po?
So actually, this is my first year also in BSYA. And masasabi ko masaya naman siya. I really get to enjoy BSYA. Siyempre, lalo na nandito din yung mga iba kong friends from Hume's ABM, which I really adore. So, what I do in BSYA technically is I'm part of the Writers Committee and the Market Committee. So, I basically do some intel and also some, what do you call it again? Some posters, yes, posters and designs, that's it. So, Shiva, let's do a shout out from the comment sections. Can you start?
Okay, shout out po kay Jana Marie Cataguis and kay Adriel Agbayan. What's up guys? What's up?
Shout out po kay May Azucena. And shout out din po kay Shernil Gabriel Tuzon.
What?
Ito, may gusto kong tanongin, Shiva.
Okay.
May jowa ka na ba?
Wala single ako.
Weh,
Yeah, I'm
can't
single.
believe that. Grabe naman. Okay. Well, I hope you meet the perfect person for you.
Okay, tagal pa ata yan, ate. Not yet interested. Study first. So, So, guys, have you heard the SpaceX Falcon 9 rocket propelled the Crew Dragon spacecraft with NASA astronauts Shane Kimbrough and Megan Arthur, along with JAXA, or the Japan Aerospace Exploration Agency?
Parang ang galing talaga, no? That, because the common misconception is about astronomical things, is that just finding about what's out there, but
Mhm.
but astronomers also finds what makes life better on Earth rather than just looking for things out there, which is really nice.
Well,
Anyway, let's. Mhm.
well, we can't just rely on our natural resources because someday we might run out of those. Someday, which who knows? Maybe that we're probably close to that point, or we're still far from it. But as we continue on living in this world, just expect a lot of changes because science will continue to evolve our lives. Science will change it, innovate it in many ways. So, shoutout po kay Sir Christopher po. Sino pa gusto magpa-shoutout po, chat nyo na lang po sa chat box. Okay guys, so Sir Lou is ready and he will now continue his presentation.
Hello, good evening. We had little technical difficulties, but somehow, hopefully we na-resolve na namin itong mga issues na yun, no? But once again, thank you very much for inviting me over to have this short talk with you about exoplanets. And for those of you who doesn't know, exoplanets are planets that are found outside our solar system. Now, the search for other planets is not a new concept. No, it has been old as philosophy itself. Actually, as matagal na rin pinag-iisipan ng mga Greek philosophers about this, no. But somehow since gamit lang ng Manila at the time was reason, was reasoning, and what they could and the things that they could only observe, they don't usually ask the right questions, but they do wonder about that. And one of them, can we go to the next slide please? And before we go to that, let us examine muna our own solar system, which is composed of the sun and then the terrestrial planets, Mercury, Venus, Earth, and Mars. And then there's Jupiter, the gas giants, Jupiter, Saturn, Uranus, and Neptune. And then there are the dwarf planets, which is Ceres, Ceres, Haumea, Makemake, Eris, and Pluto, and these are and next slide please. And then besides the sun and all the planets and everything else in between, you have the asteroid belts there, and you have the asteroid belts, and beyond Neptune there is the Kuiper belt of objects and some comets as well. So this is basically yung family of planets natin sa our own solar system. But our civilization has asked the question before, is there other worlds out there? And one of the people who first asked this question is this guy. Next slide please. Si Metrodorus of Chios, and he 4th century BC, or whichever you want to use ng time stamp na gusto niyo gamitin, but when he was alive, during this time, for the 4th century BC, this was a time when the world is believed to be the center of the cosmos, and that the universe is also finite. Ibig sabihin, when we say finite, sinasabi natin that that the universe has an edge. Okay. Plus, during this time, the common notion is that the world was flat. So, this was the time ni Metrodorus of Chios. Now Metrodorus was quoted as saying these words, and he asked the question, it would be strange if a single ear of corn grew in a large plain, although only one habitable world in the infinite. Now, yun nga, it would be strange. Analogy of this is having a 40-acre land with only one flower in the middle. So ang weird nga naman daw if kung ganun lang daw yung universe, ang cosmos natin, whereby ang malaki ang universe pero isa lang yung world natin. He was quoted of saying that. Now the next person who asked this same question came around nung time of the Renaissance, and this man's name is Giordano Bruno. Okay, now Giordano Bruno was a religious radical. Medyo radical yung ang beliefs niya. Medyo fanatic siya na konti, no? Now, during his time, he managed to get a copy of and read the book ni Nicholas Copernicus on the orbits of the planets, yung nabasa niya. Now, the idea, so there is, hello? Okay, so a radical thinker plus a radical idea, and you put them both together, what could go wrong? Pero because of this, because of the way of his way of thinking, he concluded that if the Earth is not the center of the cosmos or not the center of the universe, maybe there is no edge to the universe. Okay? Ibig sabihin, ang ibig niya sabihin, kung if the Earth is not the center of the universe, and yung edge ng cosmos natin is not edge of the solar system, it can be reached, then who is to say that beyond that is more of the cosmos? Ganun. Also with this, no, he was also meron ding philosophical questions na gusto niyang na tinakal niya, which is something like, how can an infinite God be contained in a finite universe? So yun din yung mga questions na tinatakal ni Giordano Bruno. Now, for his radical thoughts and his radical teachings, he was burned at the stake. He was burned at the stake nung 1600s. But eventually when you go to Rome today, especially dun sa tinatawag na the Square of Flowers, makikita we can find a statue of Giordano Bruno in honor of course of the man himself. As you can see, he has his arms crossed like this kasi this symbolizes na parang he crossed with the early church, you know. So ganun, he's either holding a Bible or holding Nicholas Copernicus's book. So I so ganun. Pero the question still remains na is how do we find these exoplanets? And the question was asked long time ago, but it took a couple of hundred years pa. It took a couple of hundred years pa before the technology could answer that question. So let's explore yung mga methods of detection, the methods of detecting exoplanets. So one way of detecting exoplanets is, can we go to the next slide, please? Is direct imaging. Now, direct imaging is mostly mostly using infrared sensitive detectors to find exoplanets that are relatively close to our solar system. Now, these are when we say relatively close, yung mga not really that far away sa atin kasi we have to detect infrared signals that is being reflected by the planet itself from the heat of the star, of its parent star. Now here's a picture ng example of a exoplanet which is HR 8799, no? In the center, nakita yung X na yan, that is the star in the center. Kung bakit dark yung star? Because they were able to filter out that star and na-detect lang nila yung heat that is being reflected by the planets around it. We can see planet B, planet C, and planet C and planet D. So infrared ang ginamit nung in the way of detecting tong exoplanet na to. Now, pero once again, yung usual na ginamit na detectors dito, usually yung telescopes with a very sensitive IR, who are adjusted to detect infrared signals, okay, such as the Hubble Space Telescope and the Spitzer Space Telescope, no? Ganon. So this is one way of doing it, direct imaging using infrared. Next slide. The next method is gravitational microlensing actually, no? This is medyo technical to, no? Which is, it is a lens-like effect in which light rays are bent when passing through the gravitational field of such massive objects such as galaxies, black holes, and exoplanets. So nakikita natin dito sa illustration dyan sa baba that on the right side makikita natin si Earth. That's where we are observing, and on the far dito sa may bandang yung red object, yung distant, we are looking at a distant galaxy whereby in the field of view nakaharang yung quasar with yung blue galaxy na sa gitna. So what happens is light from the distant galaxy, as it travels through space and reached the quasar galaxy or the quasar, yung light niya was bent and split. Kaya yung detector yung na-detect ng telescope with this microlensing detection is yung ganito na nakikita nyo dun sa far left, no? Where you can see the galaxy itself in the center, while yung bent light of the distant galaxy gets bent over and below ng nearby quasar. So how do we detect exoplanets using this method? Okay, next slide please. Yeah. Now, once again, if we look at the first first square, no, let's look what we're looking. Let's describe what we're looking at. Let's say yung on the bottom makikita natin yung observatory looking up towards a star, the star source on the above. Ngayon, directly on the right side makikita natin yung another star with a planet. So what happens kung pag dumaan itong planetary system na to through the field of view ng observatory, okay? When the planet passes through, makikita na that with the planet has its own gravity, it also bends the light coming from the other star, coming from the distant star. So nangyayari, nagkakaroon ng katulad ng nakita natin earlier na whereby nagkakaroon ng reflection of light from top and the bottom. Ganun din nangyayari dito. Kanya lang, instead of just 2 na magnification of light, nagiging 3 or sometimes nagiging 4, depende kung ilan yung planets na nagre-revolve around sa star na yun. So we see ganito, dumadaan yung star with the detection ng planet on the left side. And then as the star continues to move, nag-equalize yung magnified light from the distant star. And then as it moves further away, lumiliit yung one side, yung magnification on the right side, and then yung magnification on the other side nagdi-diminish until the whole system travels on and naging buo ulit yung detection ng distant star. Now, yung problema dito sa detection na to is a star has to be mag-a-align dapat yung dalawang star with another star for us to able to use this detection method. So yeah, that is kind of a hard thing to do, especially when there's a lot of stars na nagta-travel sa Milky Way galaxy natin. So pero still, this is an effective way of detecting extrasolar planets or exoplanets. So another detection method, let's go to the next slide. So this is radial velocity. Now, before we get into the understanding of radial velocity, let's talk about ito muna. This is of course, everybody, I assume everybody knows how this works, no? Starlight, you catch a starlight through a telescope, and you pass it through a prism, and then the light coming on the other side the single light breaks into a spectrum of rainbows, no? Meron tinatawag na absorption line. Okay? These absorption lines are a telltale signs of the elements that are present inside the star. Kaya nagkakaroon ng ganyan yan because of the elements inside the star. Kaya doon natin malalaman kung ano yung composition ng particular star. Now, how is this going to help us detect planets? Pero before that, next mo muna. When these spectral lines kasi shifts, sometimes they bear certain these absorption lines shift sometimes towards the red, sometimes towards the blue side of the spectrum. Now, when these absorption lines shift towards the red, the star is moving away from you. When the absorption line moves towards the blue, okay, so once again, red shift, star is moving away. Blue shift, star is moving towards you. Okay, so how does this help us detect exoplanets? Next slide, please. If a star is hosting a planet, their mutual gravity will tug on each other. Okay, katulad niyan na nakikita natin sa graphic na yan, sa GIF na yan, no? So we have this parent star and then another planet moving around it, no? And their mutual gravity is tugging at each other, and they're orbiting around a center, a common center of mass. This wobble can be detected. Ganito, yan, tama. This wobble can be detected if you look at yung kulay green na dot. Let's say that yung kulay green na dot, that's Earth, and we're observing from that position. And pansinin nyo that as the star moves away, yung letter A on the top of the spectrum, that represents the planet, and the red B underneath the spectrum, that represents the planet going around. So kung napapansin nyo, as the star moves away, the star, yung spectral lines niya is shifted to the blue, while shifted to the red pala. While as the planet moves closer to the Earth, nagsishift naman siya towards the blue. So ganun nangyayari. So in this method, kung if you're observing a certain star and it's wobbling like this, and nakikita nyo yung spectral lines niya nagsishift, red shift, blue shift, red shift, blue shift. This is a good indication of a planet revolving around that star. You know. So this is one method, another method na pwedeng gamitin to detect exoplanet. No. Actually, one of the more effective ways in detecting exoplanets, actually. And then this next method is the most used method and na ginagamit ng mga satellites, ng detectors natin today, which is a transit method. This transit method, this identifies the slight dips in stars' brightness caused when planets pass in front of it. So kung nakikita nyo dun sa GIF ulit, as the planet transits in front of the star, yung brightness ng star, kung nakikita nyo sa baba, yung graph sa ilalim, the brightness of the star dip. Now, depending on the size of the planet, dun sa kung gaano ka dim ang binaba ng star, that can determine kung anong size ng planet. And at the same time, kung gaano katagal yung transit niya across the face of the star, that will determine naman kung gaano katagal ang orbit ng planet yun around the star. Okay. So automatically, this not only tells us na if there's a planet dun sa star na yun, it automatically tells us kung ano yung size ng planet, tsaka ano yung orbital period ng planet na yun. So kung kinompare nyo yung dipping ng brightness ng planet from the left side, which is a big planet, compared dun sa planet that's on the dito sa right side, which is a smaller planet, nakikita nyo yung difference ng dip nila. So yun, automatic malakita nyo na gaano kalaki yung planet on the left side and gaano kaliit yung planet on the right side. This can also help detect multiple planet systems. So if you go to the next slide, wait for it. Yan. Okay. So here, makikita nyo dalawang planet that goes across the face ng star. And notice the double dip na nangyayari dun sa detection ng planet ng double planet as it moves across the star's face. So that way malalaman din na we could detect if there are multiple planets dun sa star na yun. Okay. So next, one more thing about the transit method is this wonderful and extraordinary, actually kind of an exciting na feature din in doing transit method. So right now, nakikita nyo, this is the Venus transit that happened on June 6th of 2012. This is the kind of transit that we're talking about. Where a planet moves across the face of the sun, moves across the face of the star. Now, this is a still picture of the Venus transit. Now, kung napansin nyo, dun sa may left side ng planet Venus, there's a very, very, very thin light that envelops that side. Ang maganda sa transit method is that when the light from the star passes through that thin layer of light, that actually kasi that thin layer of light that envelops the planet Venus, yan yung atmosphere niya. When the light hits that atmosphere and goes through the atmosphere of of an exosolar planet, yung detectors natin, makukuha natin yung spectrum ng atmosphere na yan. And by catching the spectrum from that atmosphere, malalaman natin in catching the spectrum of the atmosphere of an exoplanet, we can detect kung ano yung mga components ng atmosphere ng exoplanet. Which means we can know kung meron ba siyang oxygen, kung meron ba siyang nitrogen, kung meron ba siyang iron, kung meron ba siyang magnesium, kung meron ba siyang ganun. So, we can learn so much about an exoplanet by examining yung spectrum ng atmosphere ng exoplanet. So what we're looking for here is the telltale sign of telltale signs ng mga biomarkers, mga elements or mga components that could support life. We're talking about anybody here familiar with the acronym CHINOPS, which is CHINOPS: carbon, hydrogen, iron, nitrogen, oxygen, phosphorus, and sulfur. If we were able to detect any of these biomarkers on an exoplanet, that is a good indicator that there is life on that planet. Also, we have to consider yung tinatawag na yung circumstellar habitable zone, or CMH, or we can simply call it the habitable zone. No, this is the region around the star within which a planetary mass object with sufficient atmospheric pressure can support liquid water on the surface. Is also known as the Goldilocks zone. Itong tinatawag na Goldilocks zone differs, nag-iba-iba yun. Iba-iba yung tinatawag na habitable zone or Goldilocks zone depending on the mass of the star. So for example, on the top of this chart, nakikita natin yung our own sun, no, which has one solar mass, yung tinatawag na one solar mass. Now, we can see that along the line, kung if you follow nyo yung line ng star natin, ng sun, we can see Mercury, Venus. Venus is just reached the limit of the habitable zone. Earth is comfortably inside the habitable zone, no? So these are and then there's of course Jupiter, Saturn, Uranus, and Neptune, which is way out of the habitable zone. Now, as the star lessens in mass, katulad na to, itong orange star na to, sumunod sa baba ng sun natin, as it diminishes in mass, yung habitable zone niya gets closer into the star, moves closer to the star. So as you can see, we have Gliese 667c, which is now a lot closer than Mercury, no? And Gliese 581g and Gliese 581d. All of these planets having a lower mass star, their habitable zones get pushed further into the system, no? Mas lalo na when it's a really small red dwarf, no? Which is dun sa pinakababa, kita nyo yan, pinakababa. Yung pinaka-habitable zone niya is really close. So ganun yung ito yung tinatawag na habitable zone. This is a part of the region of the solar system where liquid can exist on the surface. Our Earth is comfortably in the center of our habitable zone ng star natin. kaya we have liquid water. And we know that without liquid water, life could not exist. That's why yung pinaka tagline ng every planet hunter or any astronomer who's looking for life outside our own solar system, ang pinaka tagline nila is follow the water. Most probably could never exist. But of course, liquid water can also exist in different ways, such as like the moon of Jupiter, Europa. Europa has a liquid water underneath that thick ice. Also, the same with Enceladus, the moon of Saturn. The moon of Saturn. Both of these moons, they're not planets; these are moons. A moon of Jupiter and a moon of Saturn. They both are outside the habitable zone, but they have liquid water underneath their ice surface. So maybe we should redefine or tweak yung definition of a habitable zone. But since we're talking about water on the surface, these two moons doesn't count. So wala lang, something to think about. Okay, so let's move on. Next slide. Now, yung natin, when we say the temperature, when we talk about the temperature, this is usually describes whether it's inside the habitable zone or way outside the habitable zone or inside the habitable zone. So for example, we have the cold, we have the temperature and cold, which is describes as exoplanets that are too far from its parent star, where water turns to ice. And then there is the warm exoplanets, which is exoplanets that are sustained within the parent star's habitable zone, where liquid water could be present on the surface. And then, of course, there's the hot, where the exoplanet is too close to the parent star that water instantly turns to gas. Okay. So ito yung tatlong categories when it comes to temperature: cold, warm, and hot. And then pagdating naman sa sizes, iba-iba rin yung sizes that we're talking about. One of them is the Jovian, The Jovian exoplanets are those exoplanets that are equal or greater than 1 Jupiter mass. Kasi yung mga early detections ng mga extrasolar planets, most of the extrasolar planets that they discover early on were either Jupiter size or up. Okay? Kasi since mas malaki siya, mas malaki yung dimming ng star, kaya mas madaling ma-detect. Kaya mas maraming nakikitang mga Jupiter-sized or higher na exoplanets. So, pero there's a limit. There is when detecting these Jovian-sized exoplanets, there's a limit where it's no longer called an exoplanet. That's something that probably you guys would like to research on. What is try to figure this out. What is the size limit where it could no longer be called a planet? Yan. Now, after the Jovian, there is the Neptunian-sized exoplanets, which has a mass of between 10 to 50 Earth masses. 10 to 50 Earth masses. These are the Neptunians. Next, we have the Superterran, which exoplanets that is between 2 to 10 times the size of the Earth. Okay, these are the Superterrans. And then there is the Terran exoplanets, which is within 1 to 2 Earth masses. Yeah, so Terran. And then there is the last category, which is in last category in size is the Subterran, where exoplanets with a mass between half the size of the Earth to one Earth mass. Okay? So here are the categories na pwedeng na when classifying exoplanet. Now we can combine these two categories to describe an exoplanet. Okay, let's say we found a warm Jovian. Ganyan. Ibig sabihin, we found a exoplanet that is greater or one Jupiter mass size na it's found in the habitable zone of the star. Okay? Or sabihin natin, we found a cold super Terran, which is an exoplanet with a mass between 2 to 10 Earth masses, pero it's so far away from its parent star. Ganyan. So you get the idea. You can combine these two categories and subcategories para ma-describe on kung ano yung what type of exoplanet that you are looking at. Ganyan. So yun yung exoplanet classes. Next is tools of exploration. Now, excuse me. The tools, the most actually before Kepler Space Telescopes, there are other satellites that had detected exoplanets already. We're talking about the Hubble Space Telescope and the Spitzer infrared telescope. No, these two telescopes have discovered exoplanets, but using the most discoveries was made by this satellite, the Kepler Space Telescope. Now, the Kepler Space Telescope was launched on March 7 of 2009, and it led to the discovery of 2,600 planets. By 2,600 planets. Wow! Parang that's kind of mind-blowing. It's considering na even before like what 50 years ago, we considering that 50 years ago we believe that we are the only we think that we are the only planets that exist that exist dito sa universe natin. And this just mind-blowing, discovering 2,600 planets. Okay? And now yung mission nito, the Kepler's mission has ended noong November 15 of 2018. But maganda ng story ni Kepler kasi when Kepler was launched, Kepler was able to view a certain patch in the sky. Yan, makikita nyo dyan. With a certain patch of the sky, no bigger than your fist, held at arm's length. Nakikita nyo yung ano niyan, yung square na yan, those little squares na ganyan. That is the area where that patch of sky is actually about as big as your fist held at arm's length. Ganyan lang kalaki yan. 2,600 planets in that patch of sky. If you're wondering, no, that's the Cygnus constellation and the Lyra constellation. No? Diyan siya nakatutok. Pero during its mission, kasi the satellite kasi has 3 gyros inside to keep itself stable looking at that direction. But when the mission started, one of its gyros broke. Okay, so pero it continued to it can work properly kahit dalawa lang yung gyros niya. But eventually one of its 2 gyros left, nasira din. So it's left with just one gyro na functioning gyro. And what happened is Kepler could not maintain its observations in that patch of sky. So they came up with next slide. And they came up with the next thing that they did. The other things that they did is that they were able to point Kepler towards the area in along the zodiac. Kita nyo dyan, Kita nyo dyan. Kung napansin nyo, in the constellation of Gemini, that's field number 0. That's yung first images na kinunan niya where he tried to find mga exoplanets. Oh, by the way, Kepler is using the transit method. Yung transit method ang ginagamit niya. So, field 0 is in Gemini. Field 2 is in the tail end of Leo. Field 2 is in Scorpio. Ganyan. So, ito yung ginawa niya nung nasira but eventually nung nasira yung dalawang gyros niya, ito yung ginawa niya. Instead of looking at one spot, he was looking at different areas along the zodiac, along the ecliptic. Kaya along the zodiac yung mga images na nakukuha niya o yung mga detections na ginagawa niya pala. But eventually nagkaroon ng complications in this sa kay Kepler. So they decided to end his mission and shut off na siya. So he was shut off with 2,600 planets discovered and thousands more waiting to be confirmed. So good job, Kepler Space Telescope and the people who built it, and launched it, Sige. Next slide. So the next detection tool na ginamit natin is ito, si Terrestrial Exoplanet Survey Satellite or TESS, TESS. Okay. Now, TESS was launched on April 18 of 2018, and currently he has discovered 2,200 planets so far. Okay, so far. Kasi hindi pa tapos yung mission niya. His mission has a duration of 2 years, pero in-extend yung mission niya. So it's still up there. The satellite is still up there and it's still doing its thing. So next slide. The Kepler satellite is orbit oriented in this manner, around the Earth. Ganito yung orbit niya around the Earth, And then kung napansin nyo, within the dome, within the shell, makikita nyo mayroong mga 4 na cameras inside. Now these cameras are designed that way for a purpose. Next slide. Makikita natin that each camera is pointed at a different angle than the other. One higher, actually 24 degrees higher than the other one. So it can take a image of the night sky in 96 degrees. In 96 degree yung niya. Now, bakit kailangan ng ganito? Next slide, please. Yan. So when it takes a picture of the night sky, kita nyo yung blue field na yan. Kita nyo yung blue field. That is the first set of pictures na kukunin niya. And then it'll take another set of pictures in a different location, which is andito sa left, nasa right side, field number 2, second observation, and then third observation, ibang field naman, fourth observation. So ang nangyayari, he was taking a 360 like a dome, 360 dome image of the night sky, and then he will turn over and will take pictures of the night sky dun sa southern hemisphere naman. So these are yung so ang ginawa ni Tess of the whole 360 degree whole sky image, just the sole purpose of detecting terrestrial exoplanet. So far, isipin nyo lang yung comparison between Kepler and TESS. Si Kepler, yung mga images na nakuha, yung mga planets na discover niya is just a fist-sized area of the sky. Compared kay TESS, he's taking the whole image of the whole 360 degree sky. So far, 2,200 na exoplanets ang na-discover niya. 2,200. But that's just as maliit pa lang yun compared pa sa other areas na hindi pa na-analyze ng mga ano. The next step is so far yung pinag-usapan natin kanina, si Kepler and TESS, these two are simply detecting exoplanets by using the transit method, no? And excuse me. So when we detect these exoplanets, what's the next step? The next step is ito, si James Webb Space Telescope. Now, si James Webb Space Telescope has a launch date on October 31 of this year. Okay. Its mission duration is for 5 years. The James Webb Telescope was supposed to be launched mga 3 or 4 years ago. Pero nakailang delays ang launch ni James Webb Telescope because unlike Hubble and unlike TESS, unlike Hubble and unlike the other satellites na ni-launch, si James Webb Telescope will be launched and deployed 1.5 million kilometers away from the Earth. So far na hindi pwedeng servisan. Not unlike the Hubble. The Hubble when it was launched, nagka-problema yung lens, madaling magpadala ng space shuttle, tapos inayos lang nila and okay na. This, however, si James Webb Telescope, which is the next generation of telescope after Hubble, hindi natin masaservicean yan because it's way out there. It's 1.5 million kilometers away from the Earth. So, hindi masaservicean to. So, yung nakikita nyong graph right there, right now, that is the planned orbits. Kasi, you can see, ilo-launch siya sa October 31 and then it will make its gravitational assist from the Earth. Mag-gather siya ng speed. When it reaches the optimal speed, it will launch itself 1.5 million kilometers to what is called the L2 point or the Lagrange 2 or L2. Yan. Why it has to be deployed in this area of space? Because in this area of space, mababa ang magnetic field interruption, magnetic field ng Earth. Medyo nag-cancel out yung magnetic field ng Earth dyan sa point na yan. Kaya dyan siya i-deploy. Okay? Yung duration of travel from launch to the Lagrange point 2, that'll take about 3.5 to 4 months. So, ganun katagal. Matagal bago umabot doon sa ano. Now, here's a size comparison ng mga size comparison ng mga apertures ni Hubble, ni Spitzer Space Telescope, at saka ni James Webb Telescope. Now, pansinin nyo that the James Webb Telescope has a 4.5 meter. He's able to detect ultraviolet light, the optical light, and a little bit of infrared. Yan. Kaya nakadetect siya ng mga, once again, kaya siya nakadetect ng exoplanet because mayroon siya nakikitang konting infrared. Ganyan. Si Spitzer naman, on the other hand, has a 0.6 meter telescope. Maliit lang. 0.6 lang na meter telescope. So, pero Spitzer is specifically designed to see the mid-range infrared all the way to the far infrared. Si James Webb, however, has a 25 meter na size na aperture. which gives him a far bigger range of detection of light. And yung nakikita niyang na-detect niyang light is part of the optical light and into way inside the medium infrared. So what does this mean? It was with this technology, with this size telescope, James Webb Telescope has the ability to better detect yung mga absorption lines na nakita natin dun sa spectrum kanina. Mas madali niya ma-detect yun sa mga exoplanets, which basically will tell us if those exoplanets has biomarkers to detect or to see if there's any indication of life on that exoplanet. So yun yung the next step to find planets that has a potential for life, or at least has a potential for life on the surface. So yun yung next step sa James, kasi we know, next slide nga po, because what we know so far. Okay, first off, the first exoplanet detected is what's called the PSR B1 B1257 plus 12. This is an exoplanet found on January of 1992 by Alexander Wolskan and Dale Frail. No, what's strange about this exoplanet is it's not orbiting a star; it's orbiting a pulsar. Okay, so yung planet na to gets bombarded by high radiation from this pulsar every minute of every day. Pero it's still a mystery kung how a planet was able to survive a catastrophic explosion of a star, tapos naging pulsar pa, tapos andun pa rin yung planet. It's still a mystery, but still, it's now worth investigating. No? Next, we have the first exoplanet orbiting a sun-like star is 51 Pegasi b, discovered in October of 1995 by Michel Mayor and Deirdre Queloz and Geoffrey Marcy. Okay, so we know that there are exoplanets orbiting a sun-like star. Next, we have a first multi-exoplanet system is found in Upsilon Andromeda. A first multi-exoplanet system was ibig sabihin a star, and then there are multiple planets orbiting it. Okay, this is in Upsilon Andromeda, discovered on January of 1997. It was discovered once again by Geoffrey Marcy and R. Paul Butler. Now, the first exoplanet orbiting its habitable zone is Kepler 186f, discovered on March of 2014. The first Earth-like exoplanet is Kepler 452b, discovered on July 23rd of 2015. And the first detection of exoplanet atmospheres. Ito parang telephone number ang dating ng mga exoplanets to. It's HD 209458b, which is discovered on 2001. The specific element that they found on this planet is sodium. And then there's HD, as better technologies and better techniques was developed, we find HD 189733b, which is discovered in 2008. Yung mga elements na na-discover nila is water vapor, carbon monoxide, carbon dioxide, and methane. So what other exoplanets na nakita? No, let's look through the exoplanet zoo. First, of course, you already know PSR 1257 plus 12, no, and 51 Pegasi b. No, we have Alpha Centauri b. This is the closest exoplanet. If you see Alpha Centauri, kasi is about 4.4 light years away lang from the Earth. So this is the closest exoplanet to us, Alpha Centauri b. We have Fomalhaut b, which has the longest orbit around its parent star. It is also the first exoplanet to be imaged at visible wavelengths. We meaning IR. Infrared ang ginamit nung kinunan ng picture ng itong exoplanet na to. We have WASP-12b. Exoplanet being devoured by its parent star. We know this kasi eventually, actually, nangyari pala dyan. Here's the parent, ito yung star niya, and the planet is a gas giant that is so close sa parent star niya that yung material, yung planetary material niya is getting sucked, sinisip-sip ng parent star itself. So eventually this thing is just gonna collapse into its parent star and become part of the star as well. Next we have ito, for those of you who are mahilig sa bling. We have 55 Cancri 55 Cancri E, no? This is a planet made of diamond. Apparently, this planet is high in carbon. It's kind of a mystery kung saan niya nakuha yung carbon na yun. Probably from material from another star that exploded. Tapos yung most of its carbon got collected and got gravitationally bound to this other star. And it's orbiting close enough sa parent star niya that the heat and pressure turns the carbon into diamonds on the surface. So, yeah, if you're wondering kung yung mga nakikita nating mga planets sa sci-fi movies na medyo weird, yeah, this is one of them. We have Gliese 667c, an exoplanet system with 3 planets that are within the habitable zone. Now imagine nyo 3 planets. Imagine nyo dun sa natin, sa solar system natin alone. Let's imagine mo that Mars and Venus is well inside the habitable zone ng star natin. Wouldn't that be great? Parang awesome yun, no? 'Di ba? Parang pwede tayong, parang pwede nating sabihin, punta ako sa Mars, visit ko yung mga relatives ko sa Mars. 'Di ba? Parang kasi the planet is in the habitable zone. It has water on the surface, which means na pwede tayong tumira doon. So this is what happened dito sa Gliese 667c, where 3 planets is in the habitable zone, which means liquid water could exist on its surface. Before I show you the next planet, no, konting geekaverse dito. Has anybody watched Star Wars Episode 4? Walks out of the house and he was looking at a double sunset. Ganon. Yeah. Well, actually, that planet actually exists. Next, that is Kepler 16b. This is an exoplanet that orbits around a binary star, or also known as a circumbinary planet. Turns out that itong system na to is composed of 2 stars orbiting a common center of mass. So dalawang star, umu-orbit sila sa common center of mass. Ganyan, dalawang star yan. And then the planet is orbiting those 2 stars. Ganun. So if you can imagine dalawang star gumaganyan, nag-orbit sila, and then a planet orbiting those 2 stars. So it's possible. Pwede. Actually nga merong mga alam ko there is a petition among the geeks, mga geeks doon out there that petition to have Kepler 16b's name changed to Tatooine. So yeah, ganun. So I don't know, wala pa akong balita if that's kung nagawa na nila yun, pero that would be really cool. Next exoplanet is Gliese 581c. Is the first potentially Earth-like planet orbiting its parent star within the habitable zone. And then we have Kepler 10b, the first rocky planet discovered, and it's also known as the smallest exoplanet. It is an exoplanet so small, it's smaller than Mercury. And then finally, ito yung one of the more extraordinary na exoplanet discoveries, which is TRAPPIST-1. No. This is known to host 7 Earth-sized planets. Earth-sized planets, with 4 of its planets orbiting the habitable zone. I mean, wow. So far among the 2,600 ni Kepler and 2,200 ni TESS, these are some of the extraordinary na planets that has been discovered. Among all of these planets, I would like to point out that among all of these planets, it's still, among all of those planets na pinag-usapan natin, none of them so far is like that. The blue marble or our Earth. So far, none of them are like that. Well, the bottom line of these exploration is not just to search for other worlds, but the goal is to search for life. Okay, life beyond our solar system, and the holy grail of this endeavor is ultimately to find intelligent life. Okay, yun yung holy grail, or actually any or every astronomer who has looked up in the sky and wondered, is there other living beings out there up in the sky looking down at us. The search for other worlds is also the culmination and the collaboration of different scientists and scientists. Well, in the late 1960s, in the early 1970s, there has been a professional divide between the different disciplines in science, like geology, biology, chemistry, physics, and astronomy, pretty much kept to themselves, with little to no information is shared among them. These information is only given if needed, but yung to openly share, medyo may divide sila. Because of the efforts of Carl Sagan. Carl Sagan kasi is one of the pioneers in astronomy, and it was Carl Sagan who first break down these walls, and he tried to convince geologists to share their knowledge to chemists, and the chemist, he encouraged the chemists to share their knowledge among the biologists, and the biologists share their knowledge again to the geologists para to discover how does chemistry affect life in a geological active na planet, ganyan, and ganon yung ginawa ni Carl Sagan. Before Carl Sagan came along, all of these scientific disciplines there are certain divides, but it was Carl Sagan who said we should collaborate and try to figure this out, and in doing so, it gives us an understanding of how the geological affects the chemistry. And then how the chemistry in the atmosphere affects yung in the environment of the climate of the planet, ganyan, and in physics, how is the position of a certain planet in a certain way orbiting a certain star affect its weather and all that. All this pioneer ni Carl Sagan, and not only Carl Sagan not only just pioneered this method of scientific sharing, he also pioneered in public sharing of these discoveries. So during his lifetime, yun din yung yung pinaka gusto niyang mangyari, is to find life beyond our planet. And our journey from knowing it, from questioning, discovery, knowing, and exploration is just it has reached a point where technology caught up with the question itself. Are we alone in the universe? We now have the technology, we now have the methods and the tools to answer that question. So yes, we are living in a golden age of astronomy. Not just because we're making discoveries like recently like the Mars rover, the Ingenuity helicopter, the Mars Curiosity and the Mars Perseverance rovers. Not just that, but also beyond our own solar system. By looking beyond and finding other planets, we become explorers. As the title says, reaching out towards the final frontier. We haven't reached far yet, but we're reaching. That's the point. We're reaching. And with sana, if and in the future, since meron na rin din tayong Philippine Space Program, hopefully we'll become participants of that endeavor to reach out towards the final frontier. So with that, I thank you very much for your time. Thank you for sharing your time and effort with me, and maraming salamat sa inyong lahat. Thank you po.
So we are going to be opening our Q&A sessions. So if anyone has any questions, they may type it in the chat box. And we have questions pala. So Ariel, may you please tell them?
Okay. Sir Lou, I have a question about
Hello.
Okay, sir. So I have a question
Hello,
po.
can you hear
My question
me?
is meron sorry po. Ano po yung technique ng James Webb Telescope para empower ka po to detect the exoplanets po?
Well, yes, it can using its infrared method, which is direct imaging. Pero it can detect yung mga exoplanets, but yung maganda kasi kay James Webb, it not only detects exoplanets, but could also read or could also detect yung kaninang spectrum ng planeta, yung atmosphere. All right, sige. So the James Webb Telescope could not only detect exoplanets, but could also detect yung atmosphere of that exoplanet. So when that way, he can tell kung ano yung mga biomarkers that can be found dun sa atmosphere ng planeta na yun. So more importantly than detecting exoplanets, it can detect life. Okay, so that's one of the I'm more interested in. Ako personally, I'm more interested in its ability to detect life than its ability to detect exoplanets. Kasi we already have Kepler and we already have TESS for that. They both can detect that mga exoplanets. But to detect life, yun yung exciting part dun . So I hope you're just as excited as me. So yun.
Yes po, sir. Thank you po.
You're welcome.
Ikaw, Shiva, may tanong ka ba? Sir? Sorry,
I have a question po sa'yo, sir. So, tungkol po ito po, sir, sa Kepler and TESS telescopes po, sir. Deactivated na po ba sila?
No. Si TESS is still ongoing, no? TESS is still up there. It's still it's tapos na nung November of 2020 . Natapos na yung 2-year mission niya nung November 2020. But NASA has deemed to extend its mission. So it's still up there. It's still detecting planets. It's still detecting exoplanets pala. Ganun. Si James Webb, smile on my face because of when we're talking about James Webb. Si James Webb naman, hindi pa nilo-launch. I-launch pa siya ngayon October. This October 31 ng October 21 of 2021. So wala pa si James Webb, hindi pa siya nilo-launch. Ilo-launch pa lang siya. So I'm excited about that kasi of its potential of discovery and its potential of exploration. Kasi ito yung kapalit ni Hubble Space Telescope, yung successor, the successor ni Hubble Space Telescope. Now the Hubble Space Telescope has given us amazing science and amazing pictures of different it made wonderful discoveries. Ano pa lang yun, nasa low Earth orbit lang yun yung si Hubble Space Telescope. This time, si James Webb Telescope will be sent so far na konti lang yung magnetic field interference, konti lang yung influence ng space weather sa kanya. So with a bigger detector pa, with a bigger eye, yung 25 meters size na I'm pretty sure na marami pa tayong madidiscover, marami pa tayong other worlds na may explore with James Webb. So natin yun. Let's wait for that. Let's wait for its launch, its deployment, and I'm pretty sure sana nga pagdating niya dun sa location kung saan siya i-deploy, mag-work siya properly kasi kasi kung hindi siya nag-work, if we sent James Webb to that location tapos somehow na may sira, then that's an 8 billion yata ginastos sa telescope niyon. So it's a 8 billion piece of junk floating out in sayang. So pero I'm pretty confident naman with the capabilities of our race of sending these kinds of missions out there. So yeah, I'm very excited na ma-launch na si James Webb Space Telescope.
Sir, one more question po, if you are willing
sure.
po, sir.
Sige po.
What will we gain from discovering exoplanets po?
For one thing is it will help us understand yung kung how our solar system was not created, but how it came to be, the origins of our solar system. It'll give us a window on how our solar system became how our solar system developed into what it is now. Okay, it will also teach us about the migration path, mga migrations ng mga planets. Kasi sometimes planets migrate. There is a current theory whereby Jupiter was once closer to the was born farther off from the sun. Pero because of its gravity, because of its size, it migrated towards the inner solar system, and it only stopped to its current position because of Saturn, yung gravitational influence ni Saturn. Na-stop si Jupiter doon sa location niya ngayon. Ito yung tinatawag na migration. We detect these migrational patterns ng mga, and this will teach us kung how our solar system becomes as it is right now. Ultimately, at the same time, it will tell us if there is life beyond our planet. Yes. Oh, it's true that there's possibility of life on other planets. Within our solar system alone, alam natin merong possibility of life. Sa Mars, there's a possibility of life. Sa moon ni Jupiter Europa, there's a possibility of life. Sa moon ni Saturn, Enceladus, there's a possibility of life. Pero what we're talking about here is life beyond our solar system and how that life develops sa system na yun. Because we know how our because we know how life started here. Basically, essentially we know how life started here in our solar system. But how life started there, yun. That's some of the questions na gusto natin malaman. That way, pwede natin sabihin, in learning about this, we can say na, that planetary system has life, that planetary system has life, and eventually baka makahanap tayo ng planetary system that has intelligent life. Intelligent life as defined as our intelligence. Life that could communicate, life that has life that has the capability of creating, designing, building technologies in order to communicate and launch spaceships, ganyan, katulad sa atin. Once again, merong konting bias in this, pero yun yung alam natin eh. That's what we know. That's what we know intelligence is. So yun yung pinaka bottom line. Yun yung pinaka yung once again the ultimate goal of any and every astronomer is to answer that question: is there life outside our planet and ultimately outside our own solar system?
Sir?
You're welcome. You're welcome.
Sir, we have another question from Julia Agosito po. Bakit po nila want ipangalan yung isang exoplanet na Tatooine? Does it look like the one in Star Wars po?
Yes, exactly. Yung nga, once again, let's go back to that scene where Luke Skywalker walks out the house and he walks towards a distant I don't know what that is, a distant fence. Tapos he's looking at a dual sunset. Ganon. And that's what Kepler 16b is. Yung nga, it's a double star that is orbiting each other, and then this planet is orbiting around those two stars. Kaya yung yung scene na yon was fictional nung the time na iniisip ni George Lucas yung scene na yon. It was fictional. But right now, well, fiction, science caught up with fiction somehow, and ngayon we find this planet. Kaya nga, I'll try to figure out nga, tingnan ko nga kung if they are successful in their petition to call Kepler 16b Tatooine. Hindi ko na follow up yun eh.
Sir, for our questions po that we have a last question po pala, sir. Sir, para po sa mga aspiring students to take astronomy po, ano po yung message niyo po for them?
Oh, yeah. Actually, no, to tell you the truth, I was one of those people who wanted to take astronomy before, but because responsibilities got in the way, hindi ko na pursue yun. But I was able to keep myself abreast with astronomy developments by reading a lot of books and reading a lot of articles. Sometimes mga scientific papers binabasa ko, sometimes depende sa kung ano man yung interest ko at the time. But ito, if you're really into, kung gusto niyo talaga maging part of the astronomical community, always remember na there will be, if you really love what you're doing, if you really like exploring exploring and answering some of the hard questions, huwag kayong mawalan ng loob. Actually yun ang pinaka message ko sa inyo. Huwag kayong mawalan ng loob. Kasi meron akong mga kakilalang mga kumuha ng astronomy na course. Medyo hindi nila natapos. Pero it's kind of disheartening for them. Especially nung mga early years ng astronomy. Kasi at the time wala pang Philippine Space Agency. So, ang ibig ko lang sabihin is, at the time, nung early years, yung mga 2000, 2003, mga ganon, if you are studying astronomy back then, when you graduate astronomy, wala kang mapupunta. There's no ready work for you here kasi walang steady, walang work talaga if you're an astronomer here in the Philippines. The only place where you can get work is either in the Manila Planetarium or Pag-asa. Pero yung usually when you go to Pag-asa, ginagawa nila most of the time kasi ginagawa nila sa Pag-asa was meteorology. So yung astronomy aspect ng ng pinag-aralan mo, medyo masaset aside yon. Kaya nakaka-dishearten nga naman talaga. But now, meron na tayong Philippine Space Agency whereby astronomers, real astronomers, kasi not like me, ako amateur astronomer ako. I did not go through the training and I did not go through the discipline and the training of a institution para maging astronomer. I taught myself. I learned by myself. Pero pag kayo, early as now, by the end of that pipeline, meron na kayong possibility na work sa Philippine Space Agency, not just in Pag-asa, not just in Manila Planetarium. Meron na kayong good chance of getting work, and you'll be able to practice your craft as astronomers. Currently nga yung mga kakilala kong mga astronomers is now working in different parts of the world actually nga eh. Yung mga nag-graduate sa RTU, yung mga si La Pearl, Nico Mendoza pala right now is in Pag-asa. And sino pa ba yung nasa anyway, yung nga. So right now, you don't have to travel a different part of the world para to practice yung craft ninyo of astronomy kung yun talaga gusto niyo. Medyo there's going to be a lot of pero beyond that, the joy of discovery is far more the joy of discovery is far more satisfying than the monetary rewards. So kung I encourage you, if you're really into science, maybe if not astronomy, maybe it's not astronomy, maybe it's chemistry or geology or biology, any of these disciplines, no? Any of the if yun yung talagang interest nyo and that is your passion, you go for it. And don't stop until na-achieve nyo yun. Ang important thing, the thing is here, if you enjoy a certain thing, if you enjoy what you're doing, then you would never work a day in your life. So, di ba? So, kung talagang astronomy talaga gusto nyo, then go for it. Go for it. And make discoveries. Make discoveries, explore, and make this world a better place. Kasi I believe that learning more about the natural world gives us better understanding of the world that we live in, and understanding science is understanding the science is a way to do that. So I encourage each and every one of you listening right now, na if you are into the sciences, then continue on, press on, continue your hard work, and I'm pretty sure that in the end, you will gain the fruits of your labor.
Thank you, sir, for that very inspirational message. So it's really inspiring knowing that from all the obstacles that you have walk upon on yung pagiging having little to no opportunities in being ganyan po. But you're still able to become one of the founders po in the Manila Astronomers po, which is really things to look up upon on. Okay.
Okay. Thank you.
Okay. Shiva, let's do the shoutouts, please.
Okay, so shoutout po sa Astro Boy na si Mr. Arnel Campos. Shoutout rin po sa mga members ng Manila Street Astronomers who are currently watching right now, especially to Miss Daniel Pantaleon at saka kay Mr. Norman Marigza. Shoutout rin po sa members ng Philippine Astronomical Society. And yeah, may shoutout pa ba? Or wala na? So,
I think that's it.
oh, that's it. Okay, so let's proceed on to the awarding ceremony then.
Yes, as well. Okay, sir. Wait a minute, please. Okay. Thank you, Sir Lou, for that informational presentation about space technology and galaxy. From the BSYA officers, moderators, and members, we would like to commemorate you with a certificate of recognition for sharing valuable knowledge as a guest speaker during the talk about exoplanet given on this day of the Lord, April 30, 2021. Again, everyone please give a smile and applause for our speaker for tonight, Sir Christopher Lu. Thank you, Sir Lu, for such an inspirational presentation po talaga. Thank you po.
Thank you. Thank you for the opportunity. Thank you, everybody. Thank you, BSYA.
Yes, I think it's already night time. It's 9:54.
Yeah.
I think at 34 OMG. Okay. So once again, I am Ariel Valeta.
And I'm Shiva Matthew V. Cruz from the BSYA. And we are your hosts for tonight. Thank you for watching, everybody. Remember to like and share. And, support this club, this amazing club. Thank you, everybody.
Yes, thank you everybody, and always remember to be safe and also fly high as an astronomer. Thank you guys for watching this webinar.
Well, I guess that's about it for this talk about exoplanets by Mr. Christopher Lu from the Manila Street Astronomers. I hope you have learned a lot, mga ka-spacers, about exoplanets by Mr. Christopher Lu. So if you have any questions or comments or reactions about this talk about exoplanets, please feel free to type in your questions, your comments or reactions in our comment section below. Wag po kayong mahiya, and we will be very glad to answer all your questions and queries. So maraming salamat, Mr. Christopher Lu from the Manila Street Astronomers, for joining us conclude Global Astronomy Month 2021. Thank you, Sir Louis, for joining us as we reach for the stars. And maraming salamat sa mga ka-spacers out there na walang sawang tumututok sa ating programang Space, the Final Frontier. Also, I would like to thank all the officers and crew and members of the BEDAN Society of Young Astronomers na nakatutok po ngayon sa ating programa. So, continue BSYA to continue to reach for the stars. And gusto ko din po magpasalamat sa mga administrators from San Beda University Senior High School. So, maraming salamat po for your continued support in our advocacy to promote the sciences, especially astronomy. So I guess that's about it for episode 15. This is your Kaspacer and Space Commander, Professor June Cahigal, saying, live long and prosper, and I will see you next time for another episode of Space, the Final Frontier. Always stay safe, everybody, and goodbye. See you in our next episode.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.
There she is. NASA's Voyager 1. Launched in 1977.
But that's just very small potatoes compared to what the Earth is involved with and knows about.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
It's one small step for man, one giant leap for mankind.